dulu. Okay, ni dah tadi. Okay, now we go to the important reactions of lipid. Tadi I have mentioned one of the most important reaction of lipid that will gives you lipid punya quality issues. So because of that reactions, lipid will have quality issues lah, especially the auto-oxidation, the crystallization, kan? It especially when for the PUFA, the polyunsaturated fatty acid, the one that has a lot of double bond, okay, so they are not actually stable, so that's why they tend to become more rancid lah. The one that has many unsaturated fatty acid. Okay, modification of fats and oil. Fats have the ability to enhance palatability of food. Always remember the one that I mentioned. Kalau kita ambil kari pap kan semalam, kari pap kalau kita goreng, if you fry in a deep fry versus the one that you use air fryer, which one have the better taste? Of course, the one that you fry in a deep fryer, because not just fat ni, dia will give you the palatability tau. Dia macam give you the flavor. Okay, so that's why some of the spices, kalau kita nak bagi makanan tu lagi sedap, kita kena fry dia dulu. Fry dulu with the fat, then only you blend or you use macam spices like apa tu, bunga cengkeh, then you have this bunga cengkeh apa lagi yang you have to make sure that it produce the oil. Oil tu yang bagi dia flavor dekat ni, bila contoh kita masak kari kan, masak kari selalu kita letak apa yang biji sawi kan, kita letak all these 4 sekawan, so you have to fry that in oil kan. Even for making soup, sometimes yang sup berempah tu, people normally sup bonjok tu dia fry dulu. Dia sebelum ada yang buat macam tu lah, okay. But some people they just put that one in water kan, to make the apa spices tu dia keluar into the sauce, the soup punya tu. Because fat ni they contribute to the palatability of food, so fat will make the food become tastier, okay. So that's why kalau kita baking, especially if you compare using butter, oil, margarine and shortening, mana yang lagi sedap? Mestilah butter lagi sedap, because butter tu dia ada high content of fat, and for certain reason the sauce from to make butter will enhance the palatability of the bakery products. Okay, because of this there is a great emphasis on the crystallization and melting behavior. So bila when we talk about fat and fat component, always the food manufacturer dia akan play around or make sure that the food is stable by having this taking care of these parameters that will contribute to the melting point or melting behavior and crystallization of the fat too, because they will affect the physical chemical properties of the fat kan. Okay, so this unique fatty acid distribution of some natural fat makes them undesirable for certain application. Okay, so macam mana nak make it desirable? So kena modify lah, you have to modify the distribution of fatty acid. Sounds easy kan, macam kita buat just take the plug and play, you know, the fatty acid SM1 to 3, you can just put the fatty acid that you want. Actually kita in food manufacturing normally they have to blend, that's why we call it blending of oil or blending of fat. Okay, so common process of modifying fat is blending. Maksudnya dia akan ambil pure TG ataupun different types of fat, dia akan blend certain percentage of different fat, blend lah, so that itu adalah sekejap saya punya hilang. Mana Zoom saya ni pergi hilang pula. Okay. And then dietary intervention, genetic manipulation. Genetic manipulation ni you have to do it early lah. Early before the biological punya genetic manipulation. Fractionation, you can fraction, you can actually modify during fractionation, process of making the process of producing the fat using fractionation, masa tu boleh modify. And then esterification and hydrogenation. Yang paling popular ni lah esterification, blending and hydrogenation that is being used. Okay, in food industry. Okay. Alright, modification methods, hydrogenation, interesterification, fractionation, and winterization. Okay, so this one, the consistency, melting point, and enhance oxidative stability. Okay, one of the major issues, in fact, because dia prone to rancidity, because yang double bond tu, dia ada double bond, dia tak stable. So bila double bond tu tak stable, when it is not stable, it will want to change to the single bond, okay? For certain reason in molecule, kita punya thermodynamic punya hukum, it always want to go back to the more stable form kan, more stable energy, right? So bila certain fat, dia prone to oxidative stability because of the presence of the oxygen lah. Development of fats and fats oil product for various product application. So why all these are being modified lah? Maybe performed before or after deodorization, steam refining or blending. These are the process of modified of producing fats and oil. Okay, but we will not go through this. Only I think I will show you one picture of how fats is being produced. Okay, lipids are modified to change their solid fat content. Remember the one that I showed you, the pure triglyceride that have a very sharp melting point yang changes to because of the solid fat content, versus the fatty food. If you have a variety or wide range of melting point, wide range of plasticity, that will give you a more favorable type of fats and oil, okay, by modifying to change their SFC, solid fat content. So the fraction or percentage of lipid that is solid at a given temperature, okay. So now if you can recall the diagram that I showed you, at a given temperature, dia punya solid sini tengok ni. Sini. At a given temperature, what is the solid fat content of that particular fat lah. Contoh kalau kat sini dia tak letak the temperature, right? The temperature. So if you actually take one T1 here, temperature 1. So if you go here and you see that the SFC or SFI, okay, is about 50% depending on the temperature. Okay, itu yang the this one lah. Okay, at a given temperature, the SFC of a lipid is a fraction or percentage of a lipid. Okay, so enable less expensive lipid to be used. So like I said, there are many types of lipid that is available in the market or in nature, but the price will be different starting from the higher one and the most expensive one, and then the lesser expensive. So one of the most expensive one is cocoa butter. So that's why kalau macam cosmetics, they use cocoa butter, the price will be higher. Okay, the cocoa butter ni, they manufacturer like cosmetic like to use it in like lipstick, in creams kan. Kalau kita tengok nanti ada they gonna use cocoa butter kan. Okay, and then also if you use it as a like lip punya ni, it can gives you macam makan coklat kan. I think Nivea, product like Nivea, apa lagi, the one that uses lip balm tu, they use cocoa butter punya formula reduce unsaturation. So if you reduce unsaturation, reduce susceptibility to oxidation lah, because unsaturation is because of the double bond. So the lesser the double bond, the lesser the susceptibility or prone to oxidation. Okay. Increase unsaturation, potentially increase nutritional quality. But at the same time, if you want to have a more nutritious oil, the one that have PUFA, okay, yang banyak macam apa tu, macam fish oil kan, dia ada omega 9 kan, so dia ada 3, you will have 3 or 4 double bond, so that will be the PUFA, so that will be more favor to the nutritional quality, so that you can actually modify. Okay, this one is just a picture to show typical fat and oil processing lah. Okay, maybe kita ambil oil bearing food satu lah. Okay, oil bearing food. So we know that oil ni kita kena extract dia dulu. Dia tak boleh tiba-tiba dia jadi oil kan. Okay, sama lah macam palm oil, coconut oil. Bukannya terus dapat oil tu kan daripada food itself. So we have to extract them out. Okay. So oil bearing fruit and nuts, for example, okay, you have to clean and wash. Lepas tu press lah, press or centrifuge. Okay, so kadang-kadang kita press terus kita dapat liquid oil filling and packaging. Sometimes you have to centrifuge and go back to the expeller, sterilize and strip. So banyak lah. There are many different processing. Okay. Oil seed ni most of the oil dalam plants dia located dekat seed dia. Okay, sometimes the oil is extracted from the seeds. Okay, so for the oil seed, you have to clean, dehull, flaking, cooking, expander, solvent extraction, or you can go through expeller. So from here, you can go through degumming, then bleaching, and then from bleaching, you can do dewaxing, fractionation, hydrogenation, interesterification. Okay. Sama lah macam animal fat tissue. Animal fat tissue ni dia kena render dulu. Dia tak boleh ambil terus extract. Render ni meaning that dia kena bagi a certain time untuk fat tu jadi more macam stable macam tu. Bagi certain time. Macam lard selalu dia orang buat macam ni lah. Lard is from pig or swine. Normally when it is extracted out, dia akan render dulu. Macam you have to leave it for a certain period of time for it to become more stable. Okay. So these are the typical fats and oil processing. So if you get the chance to do your LI in fats and oil industry, please go ahead. It is a very lucrative and exciting industry in Malaysia, especially for palm oil in Malaysia, because kita produce palm oil kan, macam saji. We once go to this in Perak also they have one very famous one. I can't remember now. I went to visit my LI student last before the COVID. A very big company also. Lamsun, kita ada Sam Dhabi also have very because Sam Dhabi is one of the biggest industry player for palm oil. So they also have their own product, and then we have Felda kan, FGV. Saji is part of FGV punya ni lah, Felda Golden Ventures punya product. Okay. Alright, this is just a processing. Okay, and then we go to hydrogenation. So hydrogenation, apa maksud? What it means by hydrogenation is actually addition of hydrogen. Okay, why do you add hydrogen? Because hydrogen can react with the double bond. Okay, why do you want to do this hydrogen? Double bond ni is the one that affects and oil that has a lot of double bond. They are liquid kan? They are liquid in nature. So if you add hydrogenation, if you do hydrogenation with nickel ni, dia macam catalyst. Okay. So you have to give certain high temperature in order to change. So this fatty acid, in this particular example, it is shown cis fatty acid. Kita nak tukar dia jadi more stable kan? Because cis fatty acid has a low melting point, right? So you want to change it to higher melting point. So this is one of the process that you can do, hydrogenation. So liquid plastic will become plastic form, melting and more stable for oxidative stability. Okay, what happens if you add the hydrogen on the double bond? So dia akan jadi saturated fatty acid because of that particular reaction. Okay, this fatty acid will be changed to saturated lah. There will no more saturated, no more double bond. So the condition of this hydrogenation reaction will also produce trans fatty acid. Itulah dia punya drawback dia lah. Okay, right? And then they will also form another trans isomer with shifted double bond. Ada juga shifted double bond, meaning that tadi dia dekat carbon 6, lepas tu dia tukar shifted double bond lah, dia tukar carbon 9. Okay. This one is very famous for macam change of margarine. Margarine and shortening are actually made this way. Okay, so that's why margarine ni dia ada, kalau if you tengok margarine punya komponen, dia tulis kat situ trans fatty acid. Actually trans fatty acid ni is not good for health punya purpose. Health punya purpose lah. If possible, we try to avoid the trans fatty acid in our diet. But that's how you get the margarine. And margarine is being used a lot in cooking, kan? Okay, cooking, bakery, banyak guna margarine. Actually, margarine is a form of hydrogenated fatty acid, or hydrogenated lipid lah. Okay, shortening pun sama. This is how they do it. The company did it. So the degree of hydrogenation or of unsaturated oil control the final consistency. Sama ada di liquid, semi solid or solid. Okay, so hydrogen attacks at the double bond. Okay, so this one is cis lah, because two of the H they located at the same location, kan? Same location. Okay, and then kalau if it is partial hydrogenation, okay, partial hydrogenation, a hydrogen atom moves to other side of the double bond creating trans isomer. So dia akan jadi trans macam ni, perpendicular. Okay, bertentangan dia punya H. So if it is a complete hydrogenation, dia akan tukar semua. It will change all these double bond to single bond. So hydrogen atom adds to each side of the double bond, saturating the hydrocarbon chain. So they will have two effect of hydrogenation. One is partial, one is complete. So kalau partial, the cis will change to trans. Okay, and then if complete, there will be no more double bond. This one is actually okay, steps in hydrogenation of double bond, C double bond at a catalyst surface. Tadi kita pakai nickel, kan, at a catalyst surface. Sometimes they use nickel for catalyst because of to make the reaction faster. Okay, so if you use nickel as catalyst or sulfur treated or copper chromide, okay, so you will have to use this, there will be surface of nickel. Okay, so this is the steps lah. Okay, the reaction are absorbed on the catalyst surface. So the blue one is the catalyst surface. As the hydrogen dissociates, so the hydrogen dissociates will attach on the catalyst surface. So this hydrogen atom bonds to one carbon carbon atom. The other carbon atom will still attach to the surface, and then the second carbon atom bonds to the hydrogen atom. The molecule leaves the surface. So competition for catalyst surface versus selective hydrogenation. This one is just to show how the step in hydrogenation if we use the catalyst such as nickel. And then we have interacerification. So interacerification is actually the changing of the fatty acid location at the triglyceride, at the glycerol backbone. Okay, if you see from here, the TG1 will have R1, R2, R3. So you interacerify, you change it. You can have a TG number 2. After interacidification, you will have TG number 2 with R2, R1, R3. Okay, so if you see this picture, you can actually change this carbon fatty acid number 2, SSN2. You can change to another fatty acid that doesn't have the double bond. Okay, so you can make the triglyceride more stable. Okay, because there is no more double bond. So and then the melting point also will be higher, right? So interesterification process can be random or can be directed. Okay. So for the products usually combined with other processing techniques. Sama ada hydrogenation or fractionation. Okay. Can also be used for base stock for blending. So after interesterification can be also used for blending after that. Lepas dia buat interesterified, lepas tu dia boleh mix two oil or two fat together. Okay. This is called blending, fat blending. So development of specialty fat and oil products is used this way. Okay, interesterification may increase or decrease or have no effect on melting point depending on which type of TG or type of triglyceride that you produce after you esterified. Okay, kalau dia tak berubah, it doesn't change the melting point. So if you remove the double bond, then you will increase the melting point. Same if you add the more double bond, it will lower the melting point. Macam tu, Okay, so this table is the melting point changes with random rearrangement. Kalau random tu dia macam tak they will do it randomly lah. Dia tak esterified macam disusun. So they just do esterification and then it will happen as the reaction goes along randomly, macam naturally. Okay. So for soybean oil, you can see that the all this oil, you can see that the original melting point, for example, soybean oil is at -7. After rearrangement, dia become 5. Okay. Cottonseed oil also increase. Lard dia tak berubah. Lard ni dia macam like a semi solid at room temperature. So if you even sebab dia punya lard punya fat is quite saturated already kan. Okay. Tallow is another fat from ruminant. Okay. Palm oil after esterification, random rearrangement, you can increase the melting point a bit. Palm kernel oil, coconut oil. This one is hydrogenated palm kernel oil, hydrogenated coconut oil. Okay. So solid fat content and cocoa butter before and after interesterification. So solid fat content is a measure of percentage of fat in the solid phase or crystalline phase to the total fat of the lipid lah. Okay. So the remainder being in liquid phase across the temperature gradient. So before esterification, dia sangat steep. Okay, the SFI at certain, for example, at 30 to 35, for example, dia terus turun from say like 78%, turun jadi 0. There is no SSI lah, SFI. But after you esterify, you can actually have a wider range of temperature. This is called plasticity is wider. Okay, you can actually use this in a better settings, a better products that you can have. You can have this the same lipid. Okay, can have the same properties at a wider range of temperature. Itu yang selalu kita nak lah. Manufacturer selalu suka macam ni lah. Okay, so if you change the temperature pun dia akan kekal sama je dia punya properties tu. Okay. So SFC is an important characteristic that influence appearance, flavor release, melt rate, shelf life and stability. Itulah selalu kalau fats and oil ni is always the shelf life and stability lah, oxidative rancidity, melting point, itu yang selalulah dia modify to have that kind of attributes. Okay. So fractionation can be done at different melting point. So fractionation ni Normally, it involves the cooling of oil to supersaturation. So this will have akan produce nuclei, nuclei yang for crystallization tu. So bila ada nuclei for crystallization, nanti you will have the grow of the fat crystals. Okay, by having the nuclei nanti dia akan produce fat crystal in a better rate lah, in a better formation. Okay, separation of solid of fat crystal and liquid phase. So kat sini kita filter, centrifuge or give the hydraulic press. Okay, different types of fractionation. You will have dry fractionation, you will have solvent fractionation, and you have the aqueous detergent fractionation. This is also part of the changing of the nucleation, crystallization in order to have different types of properties kan. Tadi kita cakap how the crystal change will affect the properties of fat kan, because of the stability. Okay, so alpha, beta prime and beta. So blending are the lipids are blended to produce various fat and oil product with specified composition. Composition ni adalah what type of fatty acid or what type of normally triglycerides lah that we have at certain food. Okay, ada food yang dia punya triglyceride dia ada berjenis-jenis. They have many types of triglyceride in certain types of food. Okay, for example, it will give you specified composition, it will give you the consistency, it will give you the stability. Okay, for example, shortening, frying fat, margarine oil, salad oil, specialty product. Okay, one of the thing that you have to do after you blending is to monitor the consistency. Macam mana nak monitor? How do you monitor the consistency? Is to do evaluation. One is to check the solid fat content, the iodine value, the melting point, fatty acid composition, so that after you blend, you will have the same similar attributes of the new product of the oil that you want, fats and oil that you want. Okay, fat percentage by weight of milk and cream. This one is just to show how much of the fat percentage by weight lah. Okay, this one tak apa. This is just to show. Actually, I thought I have the composition, but never mind. I don't have it here. Okay, I remove already. Okay. So plasticization ni the one that have wide plasticization kan. Plasticization is where it can be easily spreadable because of the crystallization. So development of the desired edible product, appearance, stability, texture in solidified fats and oil can be controlled by crystallization and or plasticization. Okay. This shortening, margarine and other solidified fats and oil product, these are all, we call it plastic solid, meaning that dia senang nak spread. Dia senang nak spread. Okay, so beta prime crystal is the most preferred plastic shortening and margarine, especially to make creaming and baking performance. Because why? Beta prime crystal are the most stable lah, most stable and has the highest melting point. Okay. Okay, this is just a product prepared from fats and oil. Okay, nak habis dah 10 minutes, lepas tu kita stop cepat-cepat. Okay, apa beza shortening, margarine and butter? So, kan, kena tahu beza kan, apa beza shortening, margarine and butter? So, butter is a fat that made from cream that's been churned into solid state. Mostly typical fat is about 80%. Okay, margarine ni is a process of apa tadi? Hydrogenation lah. Hydrogenation created when hydrogen is added. So most of it doesn't happen, maksudnya dia tak extract out like some sort of like a butter. Butter is made from actually fat of milk. But this one is actually oil yang dah dehydrogenated. So become margarine. Okay. Mostly dia buat daripada palm oil lah ni. Okay, this means it's not very reliable option for baking, but still work fine. Okay, to make shortening, so kita ada satu lagi, we call it shortening. Normally shortening ni is being used to make pie crust. Okay, To make shortening oil like soybean, cottonseed, and palm are also hydrogenated so that they stay semi-solid. So dia punya fat 100%. Kalau for margarine ada yang less than 80%, mostly 80%, but for butter, typical fat is about 80% also. Okay, this one boleh tengok percentage of fat. So this is just to compare 11 gram of fat per tablespoon. Margarine also almost the same. For vegetable oil is only 7 gram per fat per tablespoon. Macam itulah. This one is fat content lah. Okay, this is just to show kalau kita buat cake, if you want to bake a cake using different types of fats, one is using butter, one is using oil, one is using margarine and shortening. Apa beza dia? Okay, so butter will have less weight, compact and small crumb. Oil will have more moisture, tall and light, slightly coarse and open crumb. Shortening tall and light but coarse and dry and crumbly. Sebab dia tak boleh hold the moisture, shortening kan. Margarine moist but not light, coarse, air pockets and salty. So yang paling best butter lah kan. Okay, shortening. Tadi kita dah cakap shortening is a vegetable fat. Exception puff pastry and roll in shortening may contain moisture. Okay, different type of shortening for specific for food products. Okay, shortening ni dia plasticized fat lah kita panggil lah, plasticized fat. Okay. How to obtain right properties of shortening? Normally kita modify and blend. Lepas tu we do the plasticization, filling and tempering. We also need to do tempering because so that dia akan kekal dekat beta prime punya beta punya condition of the crystal. Okay. Okay, ni boleh baca kan? Baca sendiri tak? Ada banyak lagi ke ni? Okay, margarine. Okay, margarine is a plastic or liquid emulsion containing not less than 80% fat. Okay, blending of fat and oil, okay, or margarine oil formulation with unmodified oil or hydrogenation. Just remember margarine actually kita kat Malaysia, I'm not sure if we have the tub one. Normally kita punya margarine di dalam macam ni lah. Dia tak ada yang packaging macam ni kan. Okay. Will have margarine oil formulation with unmodified oil will have different consistency and oxidative stability. But for margarine, normally because of the hydrogenation process, the company will make sure that it is the most stable one lah. Okay, normally dia tak buat with unmodified oil. Okay. This one that's okay. This one is just to show the temperature, solid value, the characteristic, and the relationship influence. Okay, dia boleh baca sendiri dia pun sama. This one, oh okay, maybe this one I can explain a bit. Okay, this is a properties of random esterified vegetable oil blend. Okay, kalau kita tengok palm stearin will have about 20 and also soybean oil 20 and 80%. Okay, and then we see here for the interesterified before and after. Okay, before and after, U is the unsaturated, S is the saturated. So this one is the triglyceride percentage lah. So kalau before interesterified, you have a higher component of unsaturated. So after interesterified, you have a lesser. Normally lesser lah because you want to make the oil more stable. Solid fat content pun sama. You have about 11, 3.7 at different different temperature. Okay. Tak apa. Kalau ada banyak lagi macam ni. Okay, sikit lagi. Macam mana dah habis. Okay, tak sempat lah. 4 minit. Okay, tak apa. Never mind. I will continue this. It's already 1 o'clock because I have another appointment. I will stop here and I will make a shorter video for this important reaction of lipid, and I will post in the Putra Blast, and you can watch in there. Okay? Is that okay?
Okay, doktor.
Okay, boleh. Sebab dah pukul 1 kan. Saya ada appointment satu lagi pukul 2. Okay, I will stop here. Thank you for your attention.